Welcome to episode 2 of API. And what are we up to? We're up to TextureLoaders, weren't we? That's good news. Let's get started. Here's my beloved text editor. Yeah, right. And we've got to look into a little bit of OpenGL. So just put my thoughts in order there. And we're doing TextureLoader. So I'm going to need those two files. Well, we'll start with this one then. And it's a namespace. Namespaces. This is what's glorious. Now, OpenGL is not a language. It is not downloadable because it's just a set of definitions which the graphics card manufacturer adheres to. So it's a specification. That's all it is. This means that, where do we get it from? It's your graphics card driver. That's where it comes from. So what happens is the manufacturer does a specification, takes a specification, should I say. It matches up its functionality to that specification and then writes a driver which will list out where OpenGL can find on the graphics card each of the functional bits or switches that it needs. I'm using API, aren't we? Yeah. So that's how it all works. So you're not going to be writing in a language. You're going to just have a massive set of function calls. If you wish to look these function calls up, just look up OpenGL, use version 3, or I'd say 3.3 is probably one of the best. That goes through everything that we'll be using. I mean, we're at what? I'm at 4.5 now. I won't be using a lot of the 4.5 stuff, so I'm not really that bothered. But yeah, that's how it does it. Let's take our 3. That's got space in it. Get rid of that space. Just out of tidiness. Let's copy that over. Pop it in here. There we go. Bring it back and let's set up our functions. So TextureLoader is the class. So it's class function. Class function. And the same again. Nothing unusual so far. Except I just put a hash in there for some reason. Don't know why. There we go. Pop that through. Do the same here. Everything's looking nice and groovy. The thing we do have to take out is that equals 0 because it's in our declaration. The declaration states there is a default equal to 0. We can't put that in the definition as well, otherwise we'd be defaulting it twice. And you can't have a double default. It just doesn't work that way, it doesn't make sense, so we'll take that out. Yeah, everything's happy. So let's start here and get to my notes. OpenGL is not something I've memorized because, as you're about to see, there are rather a lot of commands, shall we say. So binding a texture. If I type in GL glue, when we initialize it, remember we haven't initialized it, we will need to do that at some point, probably in window Window 3D. Yes, somewhere in there, because we'll do all our initializations in there. Glue goes to the driver, the graphics card driver, and asks it for a list of where in the drive, or a list of functions, or where all the functions are. And it will then talk to the driver quite happily, and the driver will sort it all out for us and make sure that when we switch a switch, the correct switch is switched. Yeah, because that's all that happens. It's all switches. So, OpenGL, how much is there of it? Yeah. All of this. Lovely, lovely, lovely. There's quite a lot of it. That's just the basic stuff because we haven't initialized or set it to anything, which is, yeah. So let's activate. So active, is it active or activate? I think it's just active texture, isn't it? Yeah, that's that one. So GL, active texture, let's set that to GL underscore texture. This is how GL works. So texture 0, please. And all we're going to do to that is add slot. So if nothing's placed in there, in slot, slot will be 0, texture 0 plus 0 equals nothing, is slot 0, which is a special slot. Not. It just means there isn't anything. I've just given away how we unbind, haven't I? But yeah. And then all we're going to do is GL bind texture. And this is the lovely bit where we start doing some GL texture underscore 2D. Make sure it's all in capitals. And that's just going to be underscore text ID. That's where that comes in. If you were wondering. And that's it. So, highlighting, yeah. So there you go, there's our first GL bind texture. This is the switch. This will switch the switch for the textures onto the correct texture that we want to use. And as you can see, it uses a gluint. What is a gluint, you may ask? Well, let's just have a quick look. GLUint. Gluint is an unsigned int. Yes, now you know why I've been using unsigned int all over the place. It's so that it matches up specifically with this part of OpenGL, where everything is an unsigned int for some reason. It's the way they chose to do it. It's standard. So on most systems, it'll be an unsigned int. If it isn't, then it has a way of converting in one way or another, which it'll probably tell you that it is converting, and if it is, you just use gluint. Lovely coffee. It's really not rocket science. I mean, if you start getting a lot of conversion errors, just use gluint for OpenGL. There we go. And all we're going to do now is that line there is repeated here. And I've already, talked about how that's going to be used. Literally, to unbind 0. That's it. So slot 0 is your unbind. Yes. So you could actually bind open close brackets, or you can unbind open close brackets. If you mistakenly do the wrong thing to unbind, luckily this programming will take care of it and unbind for you. It's a really nice way. But unbinding just saves that extra action. Right, so that's your bind and your unbind. All done. No problems there. Quite nice, really. It's all switches, all switches. So let's get on to the meat and to veg. Let's do the real stuff. So colon, let's set up our variables as we always do. So I've got text ID. Here we go. What we're going to set that to? You guessed it, 0. Means there isn't one. File path. Yeah. File path. Yes, that's what we used. Is going to equal file path. Funnily enough. Nothing out of the ordinary. Local buffer. If you remember, I just wanted the address. So for this, we're going to use a special word. We're going to call it Null Pointer. There we go. It actually, if you delve into the background of what Null Pointer is on this machine, it is part of the standard library, Null Pointer _t, which is very nice of it actually. It equals 0. If you haven't already figured it out, that's what it boils down to at the end of the day if you look into it. Well, it does on most machines anyway. M_width. That's going to be a 0, isn't it? We haven't got texture. Oh, do apologise, 1 second. Oh dear. Height. We can set to 0. You've probably already gone ahead of me here again. And we needed that silly MBP. What did we actually call it? BPP. It's per pixel. Yeah. We'll make that equal to 0 as well. That's it. That's all our variables. Let's pop to here. Now, loading a texture. We are going to be using the stb_image.h, and that uses a set of functions. You can open it and have a look at it. You probably already have to find out about the hash define bit at the top. But stb image, that's how it starts. And as you can see, I get another long load of list of basically what it can do. And oops, went outside it. There we go. And what we want to do is we want to set it up. So we're going to set flip vertically on load. Again, it's a switch. It's either on or off. You can put a 0 in for off, and we're going to put a 1 in because Opengl works in the reverse order to what we do on height. Why it does, don't ask me. It's just the way it, I mean, Opengl dates back to the 90s, and in the 90s they thought it was a good idea that Opengl should start from the bottom left, not the top left. Simple as. Or reverse, depending on which machine you're using and how that machine converts its images. So to make sure we have that function for you. Now, if you're on a machine where it doesn't need to be done, just put 0 in there. You'll soon find out, trust me. Local buffer is where we're going to store our image, our texture. And that will be stbi. Oh, this is a complicated one. Load. And now we just need all the variables, so it's going to be file path. Yep, there it is. And we're going to have to convert that to C, aren't we? Because stbi is a C header. So, just pop that into C for it. Very kind. We asked for the path as an address, so that's already done. So we'll need the addresses of everything else as well, which will be width, the height, and the MBP, yeah, that per pixel. And of course, there are 4 bytes per pixel. We have an RGB and an A. Bing. So I'll put that in at the end just to let it know that that's how many we want. Sometimes called a depth, but hey ho. Call it what you want, really. Now, for sanity's sake, in case of errors, which I doubt there will be any, but just in case, and we don't really know what's going on behind the scenes, I'm just going to do a quick printf from C, because we have that in our machine. And all I'm going to do is put the escape character in for a new line. Don't need a space. And what I'm going to do is put texture loaded, and that's a %s. There we go. Lovely. And that's just going to be file path, isn't it? Yeah. Again, printf is C, not C++. .c underscore string. There we go. That makes sure we get everything there. Lovely. I think I'm happy with that. Might go a bit further on that, but not now. No, I don't think it's worth doing much more. You can print out, well, printf the width and the height, so you can double check that it's doing the right thing and it's coming back with the correct values. That's a possibility. You'll know if it's not, or hopefully you will anyway. GL. Right, first of all, you'll spot this as we go through OpenGL quite a bit, that the first thing that we're going to do is generate. So GL, gen textures. You'll get used to this kind of thing quite quickly. With OpenGL, we'll just have one of them, please, because we're only doing one at once. And you'll want the address of text ID. There we are. That's that done. So we've generated our texture, which is mTextID. This is going to basically tie everything together for us, very kindly, for the binding, which we will do next. Yes, we are going to bind the texture. Yeah, we're just thinking, no, we only need to bind it, don't we? We don't need to set it at this point, because we're not going to actually use it, we're just recording this. Texture. We're doing the generation. Oh, I can't do it that way. Sorry, all capitals, texture. Always get that wrong. Always. There we go, texture ID. There we are. That's all we need to do with OpenGL to switch the switches, to make sure it binds our texture to the correct place. It sounds really far-fetched, doesn't it, that this is actually going to work? It's because OpenGL isn't a language, it's just a state machine. You switch switches and it works. It's really that easy. It's just knowing which switches to switch, in which order, and how. Mostly the order doesn't matter, but there you go. Now, what we're going to have here is parameters, and I need the integer version. Parameters, not the float. I stands for integer, F stands for float. You'll get used to that as well. And that's a GL texture, usually. 2D. I think you're getting the hang of this. Bit repetitive. Texture. This part isn't. Now, which texture do we want? We want min. We want that minification. Minification filter, please. Yeah, it's already chosen it for us. Good, thank you. It knows what we're doing. And we're going to put that at to linear. There are various other things that we can do, but GL linear is by far the most popular. Different things you can do with this text parameter, GL text parameter. A good idea is to look it up and have a look at all the different variations on it, but there are a lot. I'm just going to do some basic ones. This tells OpenGL, or our graphics card, should I say, how to use our texture. The minification and the magnification. That gives it away, doesn't it? So, in the distance and up close, all I want it to do is convert our texture in a linear way, shrink it and magnify it in a linear way. It's called interpolation, but that's beside the point. In a linear way, so that it fills the screen or shrinks into the distance in a normal way type of thing, sort of, if it works. Depending on the texture's size, because we're using 256 by 256, but I just chose that at random. The better the quality of the texture, the higher the number. In other words, 1024 by 1024 will be very, very good. But of course, that's going to be a lot of memory. So that's the trade-off. I use 256 by 256 because it's a nice, easy figure. And I think it's about half a K, isn't it? So it's not massive. It's not a massive amount of memory that I'm using up. Now, we'll just take the first part of that to the comma, please, because we're going to just do a couple more. Here we go. Next one that I want is going to be wrapping. How does it wrap around our object? So it's texture, wrap. These are things that I would advise you do. This one is _s. You're thinking, _s, what does that mean? GL_clamp. It is obvious what it means. Clamp to edge. That's exactly what it says. Take our texture and clamp it on an edge before you make sure it goes all the way to the edge and make sure it fills our object to the edges. Yeah, that's what it actually means. Texture wrap S. Well, yeah, okay. Let me just put the next line in. Tell you why. Once upon a time in the West, there was a 3D programmer, and they didn't have OpenGL, so they wrote it. And they decided that the texture coordinate system was going to be S and T. I don't. I use U and V. Some people still use S and T. I think that's a bit old school. Maybe it is. Maybe it isn't. Don't know. It's your choice. You can if you want. But I use UV because UV coordinates you've seen in Blender. You know what a UV coordinate is. It's the XY coordinate of a texture. So ST, UV, XY, they're all the same thing. When referring to a texture. So that's why it's S and T. I bet there is a U and a V version by now. So we've switch the switches to generate the texture and bind it. We've told our graphics card how we want the graphics card to manage our texture, to magnify it and minify it, how to wrap it around our object. Now we need to start funneling in the data. A local buffer. So, this is how we do it. We open up, or we ask OpenGL to use the correct texture module, as it were, because there are different ones. So we're going to use this module, which is image 2D. You'll see that come up later on, in fact, in this series, in the API series, when we come to putting our data across to OpenGL, we will see this texture thing come up again. And I'll probably talk about it more there, but that's the module that we'll be using. It needs to know quite a few things, unfortunately. It needs to know everything about the data. You'll see the same as we do the Opengl Loader, that this is how it decides it wants its information. Because our graphics card knows nothing about our data, everything has to be described to it. As you can see from my tooltip, we need a GLint level. So, is this levels 0 to infinity? I think there can be 32 of them actually. We're just going to use 0. We're going to use the first one, which is 0. And it's going to be, how did we save it out? We saved it out as RGBA 8 bits. So RGBA 8. There we go. That's how we saved it out from, I think I used GIMP, if I remember rightly, going back to the setup. That was a few days ago, don't worry. Next it's asking me for the size, which is width. It's then going to ask me for the height, isn't it? Yeah. Isn't that handy that we've got all these variables? Now it wants to know the border. No, thank you. We don't want a border. So I'll put 0 in. You can put null in if you wish, but I just put 0 in. Format. Again, what format do you want it to be stored in on the graphics card? Yeah. Not what format have we stored it in, but what format is the graphics card going to use? Well, it may as well be the same one, RGBA. We don't need the 8 because let the graphics card choose. It could be a 64-bit graphics card. I don't know what it is. I haven't got a clue. So let it choose. So GLE num type. What's that asking for? Darn good question. Darn good question. It's actually asking for MBPP, but we're not going to put MBPP in because that's really not going to tell it. It's that 4. If you remember, I put a 4 in. Well, that is as a value, or is a GL unsigned. If you remember, things in GL are unsigned, and it's a byte. If I'm thinking correctly, I'll check that after. I think it is. And then the last item it's asking for is the pixels, which is m_local buffer. There we go. Ain't that good? I'm interested. What's it tell me that is? Oh, it just tells me that it's OX1401. It's 4. No, it isn't. It'll probably be 8, won't it? Because it's a byte, not a bit. Oh gosh, I'm going mental. Let's just go back here. Let's pick a nice place. That's a nice place. Do that. Let's get it all. I'm just splitting the lines down so it fits on my screen better. There we go. That's that bit done. So that will feed it down to OpenGL. And how that is done is using the next part of the API, which is the Opengl Loader, which goes on to use the last bit, which is the GLSL. So I'm doing this in line, as it were. This is the first part for the image. We've already loaded the model, so now we have the image and the model. They're all being funneled down and all be stored onto the graphics card. So now it's stored on the graphics card, we don't really need to know about it anymore, so we can unbind it, of course. We've written the function, so I'll use it. There you go. Now, one of the things that STBI does is, well, OpenGL as well, and also C++. It allows us to check local buffer. And if that returns positive or true, it means there's something stored in it, which is handy. If there isn't anything there, i.e. it's a null pointer, it's false, because the null pointer is 0. And if it is true, then STBI, our last instruction from that header file, is simply that we want to free up the buffer and the memory. And that's it. So what we've done is we have loaded it, we have generated it as an OpenGL texture. Sorry, we have generated an OpenGL texture switch set. We have told our graphics card how to use it. We have sent it down the pipeline for OpenGL, which will go through to GLSL as the next stage. And we've unbound it. So in other words, we've sent it to the graphics card. We've then unbound it, and because it's on the graphics card, we have then checked to make sure that there has been an image, and in case there's any errors, we don't need that line if there is. And if, as the image is there, we then, well, free it up. We free the memory up. That means we don't delete the local buffer, we just free the memory up, which means it's no longer counted in the system as being used. It can be reused by the system. That's the most important definition there. I can't say it's been wiped, because it hasn't actually. But don't tell anybody that. It's been freed up for the system to reuse. That's the important thing. Memory management. C++ programmers' nightmare. Yeah, okay, that's got some strange things in there. Okay, that's it. That's everything. Now, I was going to write a test for this, and I did try writing a test for this, and then my head hit a brick wall, and I said, what the heck am I doing? And the answer was, I'd forgotten something. We can't write a test for it because we don't have OpenGL. OpenGL at the moment is provided to us by Glue, and it's provided to us on the basis that we have initialized Glue, and nowhere in here are we doing the initialization, and we're not going to. That's all going to go in our window class. All initializations for everything will go into the window class, so we can't test anything until we've written that window class, and that's in the next series, unfortunately. It's probably the first thing that we do in that? I don't know yet, haven't decided. So that's it, there you go. You've now got a texture, you've loaded it, you sent it to the graphics card, and you freed up the memory for the main computer system. All the important points covered. Bind and unbind, we have a way to do that. Save it out. Save it out. I need to do a quick check to make sure it's correct. So I'll do that with a Control-Shift-B for build. It's going to take a while. There we go. Done. It's correct. No warnings, no nothing. It's quite happy. GluInt is an unsigned int after all. As you know by now, we would have gone warnings for conversions, and I've shown you all about that in the errata for the last series or the last stage. So we know at this point, or we are 99.9% sure, without checking our code using something else, that we are right, that everything is correct, and we now have, most importantly, our texture loader. And with that, I am happy. I'm happy that everything is working properly. There we go. Our secure no warnings is working properly. Yeah, I'm happy. Happy, good, done. So, onwards to our Opengl Loader. That might be a slightly bigger marathon. It's the largest part of the API that I'm going to write, and it's going to cover everything, including the texture part. Well, who's going to run this texture loader? Well, Opengl Loader is going to run the texture loader for us. I was thinking of leaving it to the user, but it's going to be half and half, shall we say. You'll see how it all works out and pans out, I suppose, from there. And because I'm happy with it, I'm going to store it. Is that all we've changed? Oh, it will be, because this is the second time I've written it. Typical of me. Let's just go back here. Sorry, but I have to be sure that things are working correctly. So I'm going to delete you. I am going to delete you. I'm going to get a ton of messages now, aren't I? Yeah, of course I am. Yep, that's on the right thing. Control-Shift-B for build. Nope, it's just filled in, it's done it. That's fine. It's happy. Wow. I could delete the whole thing, can I? No, I'm not going to do that at this stage. What I'll do is I'll double check it using other utilities and things. So I'll do that behind the scenes, and I'm going to let you get off now for your cup of coffee, because I've got mine here. So cheerio, and I will see you in the next episode as we dive headlong into the heart of the API. Take care, and above all, have fun.